Hi, so we're going to talk about writing the characteristics of a sine or cosine function if you're just given the equation. So we're going to talk about amplitude, period, midline, domain, and range. So this first one is a sine function. I'm just going to sketch what the parent graph for a sine function looks like if it's just sine of theta. So it's the one that starts at 0, 0, and then this just keeps repeating over and over again, this little wave. Okay, so let's talk about just what a, b, h, and k are in this function. So a is 2. That's the number in the front, the coefficient. B is 4. That's this number right here in front of the variable. There is no h. H is the horizontal shift. There's nothing inside parentheses with the variable, so I'm just going to put h as 0. And then k is 5. That's this number added at the end by itself. So let's start with the amplitude. Amplitude is the absolute value of A. It's how much the vertical stretch or compression is of the graph. So it'd be absolute value of 2, which is just 2. So that's telling us that this goes up to 2, down to negative 2. Let's try period. So period of sine and cosine functions is 2 pi over b. And the b in this equation is 4. So 2 pi over 4. If I simplify that, I just get pi over 2. So that's saying that this wave repeats every half of a pi. So if I'm just transforming the parent function, this would be pi over 2 instead of 2 pi. Let's talk about the midline. So midline for the parent function is 0, but since this function shifted up 5, this will be 5 now instead of 0. So I'm going to put y equals 5. It's basically just whatever the k value is. So actually I'm going to put y equals k, and that means it's y equals 5. So it's the vertical shift, whatever that number for k is. That's the midline. And make sure to put y equals because of the equation of a line. Since we shifted up 5, then everything's going up 5. So that means this highest point, instead of 2, it's shifting up 5. I'm just going to erase it. And it's going to become, let's see, it was 2, it's moving up 5, so now it's 7. And that's going to help us with our range later. And then this lowest point at negative 2, that's shifting up 5. So I'm going to erase it. If it was at negative 2 and now it's shifting up 5, I'm going to do negative 2 and add 5 to that. And now it is at 3. So my amplitude is still 2. It's going from a midline of 5 and up to 7. That distance is still 2. So that's still the amplitude. We just shifted everything up 5. Okay, so let's do domain and range. Domain. For every sine and cosine function, the domain is just negative infinity to positive infinity, or all real numbers, because this wave just keeps repeating over and over again. It doesn't have any restriction on its domain. And then the range depends on where the highest and lowest points are. So the lowest point is 3, and it goes up to 7. And I'm using brackets, square brackets, because we're including 3 and 7. It actually touches at those points. Let's try another one. All right, so we're going to do, let's say, negative 1/2 cosine of 1/2 theta minus pi over 4 plus 3. Okay, so let's identify a, h, and k. And actually first I'm just going to sketch a little cosine function, what the parent would look like. So it's the one that starts high, goes low, goes back up, and then this just keeps repeating over and over again. All right, so a is the number in front, the coefficient, so it's negative 1/2. B is the number in front of the variable, it's just 1/2. And remember, sometimes this will be a theta and sometimes it'll be an x, and it doesn't matter, it's just a variable. H is the horizontal shift, it's pi over 4, so that means it would be shifting to the right, pi over 4. And then k is 3, that means it's going to be shifting up 3. Let's start with the amplitude. Okay, so the amplitude is the absolute value of A. So it would be the absolute value of -1/2. So just a half. So that means this is going to flip upside down because it's negative. So instead of starting high, it's actually going to start down here and then go this way. Okay, so now it's flipped upside down, and then I'm going to mark the amplitude for the parent is just 1, but now it's a half. So this is only going up to a half and then down to -1/2. So it's been compressed. It's been vertically compressed by a half. So the amplitude is basically just whatever the vertical stretch or compression is. Let's try period. So period is for any sine or cosine function, 2 pi over b. b was a half. So it'd be 2 pi over 1/2. And then let me just show again where I'm getting b from. It's the number right here in front of the variable. So that's where that half is coming from. 2 pi divided by a half means the same thing as 2 pi times 2 over 1. So we get 4 pi. So that means one cycle of the wave would be 4 pi. The parent function is just 2 pi. But that 1/2 transformed it, so now the period is 4 pi. So one wavelength is 4 pi units long. Midline is y equals k. So it's however much you're shifting up and down, and it's just this line that goes through the center of the curve. Since we shifted up 3, k is 3, that means it's y equals 3. So then this is now 3. This midline is not 0 anymore. It's not the x-axis. It's been shifted up 3. And that means the half right here is also shifted up 3. So instead of being at a half, it moved up 3, and now it's at 3.5. So I'm going to write 3.5. And then the -1/2 down here was shifted up 3. So if you're shifting that up 3 units, you're at -1/2. And you go up 3, that means you add 3 to it. That would be 2.5. Positive 2.5. Okay, so you can still see that the amplitude is still a half. The midline is 3, and then it's going up to 3.5, and it's going down to 2.5. The amplitude didn't change. It's still a half. So I'm still just double checking my amplitude. It's still a half. Let's do domain. So any sine or cosine function, -infinity to +infinity, and then range. I'm just looking at the minimum point, 2.5, and it goes up to 3.5 at the highest point. And we're using square brackets every time because it's touching those points. By the way, this function also shifted. We said because h was pi over 4, it does shift to the right pi over 4, but that doesn't change any of these characteristics that we write out. Amplitude, period, midline, domain, range. None of those will change if it is shifted to the right pi over 4 or if it's shifted left or right. So the h value doesn't affect any of these characteristics.